Hello everyone, good afternoon. How are you today? Am I audible and my screen is visible to you? Am I audible and my screen is visible to you? Okay, so today you have given a test paper, right? So we are going to discuss about that given test paper. Okay, let's start with our session. First question here is what is the maximum number of orbitals that can be identified with the following quantum number, that is n is equal to 3, L is equal to 1 and n is equal to 0. So you know when n is equal to 3, that is principal quantum number, the orbital is what we write it like 3. Okay, and when L is equal to 1, you know L is equal to 0, it is s orbital. L is equal to 1, it is p orbital. L is equal to 2, it is d orbital, and in that way. So here L is equal to 1, that is it is a p orbital, right? When we talk about m value here is what? 0. Okay, m value here is what? 0. So when m value is 0, you know that m value when it is 0, when m value is lies between plus L value to minus L value, plus L value to minus L value. Okay, so when we talk about plus L to minus L value, so here it means what? It is between 1, 0, minus 1. It is between 1, 0 and minus 1. So when m is 0, which type of orbital will be present here? Okay, when m is equal to 0, which type of orbital will be present here? So since here m is equal to 0, so you know that p orbital, there are different p orbitals present. So out of that p orbital, here which orbital will be present? M value will be in between plus L to minus L, that is plus 1, 0 to minus 1. Okay, so here it will be which orbital? It is a 3 orbital which is having magnetic quantum number 0. So it should be what? 3pz. It will be what? 3pz. So how many orbitals are present here with this quantum number? 1 orbital. That is which orbital? 3pz orbital. Okay, it will be what? 3pz orbital. Next, calculate the energy corresponding to the light of wavelength 45 nanometers. So here wavelength is given, Planck constant is given, speed of light is given. We need to calculate the energy. So what is the formula for energy? Energy is equal to hc by lambda, right? Let's put all this value here. Energy is equal to hc by lambda. Put value of h, that is Planck's constant. Put value of c, that is velocity. Then put value of wavelength, which was in nanometer. I have converted it into meter. When you do all these calculations, now you will get the answer 4.4 into 10 raised to minus 18. And which is which option? Option E. Yes, very easy problem. Okay, any doubt regarding this? Okay, let's move on to the next problem. If A is the length of the side of a cube, the distance between the body-centered atom, one corner, the distance between the body-centered atom, one corner atom in the cube will be. So what will be the distance between the body-centered atom and the atom which is present at one corner? So you know this is our what? Cube. Okay, so the cube distance is how much? Root 3a by 2. Root 3a by 2. So that is which option? Option number D. Right, option number D. Very good. So now let's move on to the next problem. So here which property of collide is? Which property of collide is dependent on the change on colloidal particles? So as we know, this effect is what? Tyndall effect, which is arises due to the scattering of light and not due to the charges. And that's why here our answer will be what? Yes. What will be our answer? Tyndall effect. Okay, not depend on the charge on the collider particle. That is what about Tyndall effect. Yes, any doubt in this? Okay, let's move on to the next problem. So here, what is happening? Which of the following salts will give us highest pH in water? So KCl, NaCl, Na2CO3, CSO4. When you dissolve into water, now what will happen? Whether it will give H plus ion, whether it will give OH minus ion into the solution. Okay, or when it dissolves into water, what is going to form, and when it reacts with water, what we are going to get? So when we dissolve KCl in water, what we are going to get is KCl plus H2O. So what happens here is when we do any dissolving property for KCl, NaCl, and CaSO4, you can find out that there is no liberation of any kind of OH minus ions. Okay, so here what is happening for Na2CO3? It is a basic due to hydrolysis of CO3 2 minus ion, and which reacts with the water molecule present in the water, and they form OH minus ion, and that's why their pH is highest in water. So your answer is what? C. Okay, let's move on to the next problem. On the following 0.10 molar aqueous solution, which one will exhibit the largest freezing point of depression? So as we know, for freezing point depression, we consider if there is any molecule present, KCl, or here molecules are given KCl, here glucose is given, here K2SO4 is given, here this aluminum sulfate is given. So here in this molecule, we need to consider how many ions are present. Okay, because after happening of in order to happen the freezing point depression, here we need to consider how many ions are present in all the molecules. Okay, it depends upon that factor, right? So when we talk about our formula, delta TF is equal to IKFM. What is I? I is what? It is what? Number of ions present in the given solution. So for Al2SO4 thrice, how many ions are present? Actually 2 Al2 plus are Al3 plus are present, and 3 SO4 2 minus are present. So total 5 I value is what? 5. But for other molecules, the I value is not that much. Okay, and that's why your answer will be what? Option C. Okay, yeah. Next, when 22.4 liter of H2 is mixed with 11.2 liters of Cl2 each at STP, the moles of HCl form is equal to. So here, H2 plus Cl2 gives HCl. Simple reaction. Okay, H2 plus Cl2 gives HCl. This is a very simple reaction occurring. Okay, this is its concentration is given 22.4 liter. Its concentration is given 11.2 liter. How many moles of HCl are going to form? So here you can see that the number of mole volume or the quantity of volume for H2 and Cl2 is unequal. So the number which is less, that much amount of product is going to form here. Okay, the amount which is less, that much amount of product is going to form here. So see here 22.4 liter of H2 and 11.2 liter of Cl2 is there. So this is what 1 mole. Okay, but this is what half mole. So since this is in excess quantity, so limiting reagent here is what? Cl2. This is excessive reagent, and this is what? Limiting reagent. Since we know that limiting reagent describes or concerns about how much amount of product is going to form. So since half mole of Cl2 is present, so that is limiting reagent. So 1 mole of HCl is going to form, because in H2 plus Cl2, from 1 mole of Cl2, we get 2 moles of HCl. So from half mole of Cl2, how much we are going to get? We are going to get 1 mole of HCl. So your answer will be what? Option A. Yes, any doubts in this? Okay, let's move on to the next problem. Here 0.1 mole of MnO4 minus is oxidized with quantity of electricity required to completely MnO4 2 minus to MnO4 minus is. So here we need to consider the conversion factor. Okay, we need to convert MnO4 2 minus to MnO4 minus. So when this happens now, here what is happening? The valency factor here is what? 1. So since 1 is the valency factor, and what is the concentration of it? 0.1 molar. Okay, so for 0.1, when we calculate the electricity, now we multiply it by 0.19650 charge form, multiply here 0.16, and that's why we are getting the answer. What will be the answer here? Yes, this 9650. Okay, any doubt in this? Okay, let's move on to the next problem. Okay, for the reaction, this is the combustion reaction at constant delta H and minus delta E. What will be the value for this factor, delta H minus delta E at constant temperature? Delta H minus delta E, what will be the value for this factor? This is a combustion reaction. We have seen C3H8 reacts with oxygen to give CO2 and H2O. So for this reaction, you can see 3H2 and 4H2O, 3 CO2 and 4H2 are forming. Okay, so delta N we need to calculate for this reaction. And what is delta N? It is what? Number of gaseous moles of product minus of reactant. Product minus reactant is what our delta N. But water products and water reactants, we need to consider the number of moles. So how many number of moles are present in the product? 4 plus 3, 7. Okay, 4 plus 3, 7. So number of gaseous molecules of product. So यहाँ पे क्या है? Liquid. Liquid हम नहीं consider करेंगे. Only gaseous consider करेंगे. So here in product 3 are present. And here in the, what we can say that reactant side 5 plus 1, 6 are present. So overall, how many gaseous atoms are present? 3 minus 6, that is minus 3 gaseous atoms are present. So this is our what? Value of delta N, and we know the formula. Delta H is equal to delta E plus delta nRT. Okay, delta H is equal to delta E. Delta H is equal to delta E plus delta nRT. Okay, the formula is what? This way. Delta H is equal to delta E plus delta nRT. So what is the value for delta N? We have calculated minus 3. So just put that value. You will get the value for this is what? Minus 3 RT. Okay, minus 3 RT. So what is the answer for question 60? Answer will be what? Option D. Next, weight of silver displaced by quantity of electricity which displaces 5600 ml of O2 at STP value. So here, how much amount of weight of silver is going to displace? Okay, so here consider the equation. So 5600 divided by what? 22400. So here we are calculating the number of moles of O2. How many number of moles? 1 by 4. Okay, how many number of moles are present there? 1 by 4. So when you do the calculation with the help of electrolysis law, you can see here what is happening. The weight of silver divided by molecular weight of silver multiplied by what? Its number of moles is equal to weight upon molecular weight into 4. Okay, so this is the reaction. So what is happening? Let's put all the values. Weight of O2 is what? 1 gram. Okay, and divided by, means weight by molecular weight is nothing but what? Number of moles, which is given. Okay, so that I have put 4 will get cancelled. Okay, sorry for this. Something is wrong with the pad actually. Okay, so 4 will get cancelled here, and what will happen? We will get weight upon 108. Okay, it will be equal to what? 1. So weight will be how much? Weight of silver which was displaced will be what? 108, which is shown here. Okay, so this is very simple formula and very simple problem. So your option will be what? D. Yeah, any doubt in this? Okay, let's move on to the next problem. Which of the following statement is correct for the spontaneous adsorption of gas? So when we have seen about the adsorption of gas, during the adsorption of gas, what happens? Delta S is negative, delta H is positive, delta S is negative, delta H is highly negative, delta S positive, delta H negative, delta S positive, or delta H highly positive. So we have seen about delta H and delta S value. You know that when we talk about delta H and delta S, we need to consider the Gibbs-Helmholtz equation, that is delta G is equal to delta H minus T delta S. Here we have seen that for the adsorption process, delta S is always negative. So delta S must be negative in order to have delta G negative for the spontaneous reaction. Okay, so that's why here what will be happening for this problem, what will be the value for delta S? Delta S will be negative and delta H should be also, it should be highly negative. So that's why here option B will be correct. Right? Okay, let's move on to the next problem. For this given reaction, see, I have solved the problem here. Given reaction X2O4 is giving us XO2. Delta U is given 2.1 kilocalorie. Delta S is given at 300 Kelvin. Okay. So what will be the delta G value? Right? What will be the delta G value? So here, this has been repeat. Okay. Itna repeat ho gaya फिर से. Okay. At 300 Kelvin. Itna hi hamara problem hai. What will be the delta G value? So you know the formula, delta H is equal to delta U plus delta NG RT. Right now, just we have seen this formula. Delta U value put 2.1. Delta NG, you can calculate it from the product side, from the reaction, that delta NG is equal to what? Number of moles of the product which are in gaseous state minus number of moles of reactant which should be in gaseous state. So here liquid is present in the reactant side. That's why the number of moles of gaseous atoms in the product will be 3. Okay, so sorry, not 3, 2. Okay, 2 moles na. Okay, 2 into R की value लेना है हम लोगों को 2. Okay, because this is what calorie per Kelvin. That's why I have taken 2. T का value लिख लो 300 divided by what? 1000. Okay, divided by 1000. So delta Ng RT is equal to what? 1.2. So when you calculate this now, you will get value of delta H, that is 1.2. Okay, in out in this. Okay, let's move on to the delta G calculation. Delta G is equal to delta H minus T delta S. Okay, delta H is equal to delta H minus T delta S. Put the value of delta H. What is that? 3.3. Okay, minus 300 is the T ka value. Delta S ka value you can write. See here, it is what? 20 divided by 1000. Okay, 20 divided by 1000. So here, delta U value was in kilocalorie. Okay, so here I have converted the value of calorie, that is R ka value, in terms of what? Kilocalorie. That's why 1000 I have written here. Here also for delta S, in order to convert it into kilocalorie, we have written divided it by 1000. Okay, so when you calculate all this now, you will get the answer 2.7 kilocalorie. In order to get the answer in kilocalorie, we have divided the term by 1000, right? Okay, so that was our answer, minus 2.7 kilocalorie. Okay, so for 64, the answer will be P. यहाँ पे देखो A में प्लस लिखा है, साइन ही नहीं ना, यहाँ पे माइनस साइन है, इसलिए हम लोगों ने ये चूज किया. Next, how many milliliters of 0.1 normal H2SO4 solution will be required for complete reaction with a solution containing 0.1 to 5 gram of pure Na2CO3? So here, how many milliliters of this H2SO4 is going to required? So for this reaction, we need to consider about the mole concept. That is equivalent concept. That equivalent concept means what? We need to consider milliequivalent of H2SO4 will be equal to milliequivalence of Na2CO3. That is what our formula. Milliequivalence means what? The normality which is given 0.1 into millimoles of H2SO4 will be equal to millimoles of what? Na2CO3. Okay. So here, milliequivalence, how you are going to calculate? 0.1 is what? Normality. V divided by 1000. Volume we don't know right now here. And 0.125 divided by 106. 106 was what? Na2CO3 molecular weight and multiplied by 2. ठीक है, वेट दिया था, उसको डिवाइड किया मॉलिक्यूलर वेट से, वी गेट द नंबर ऑफ मोल्स मल्टीप्लाइड बाय द 2 टर्म. Okay, multiplied by 2 milliequivalents of Na2CO3. When you do this calculation, you will get volume 23.6. That is option A. Okay, यहाँ पे 25 है, it is 23. Just see all the answer 26.3, यहाँ पे 32.6. Okay, so answer A is correct here, right? Now let's move on to the next problem. Okay, here you can see what is happening. Be2 plus is isoelectronic with which of the following ions? So Be2 plus, how many electrons are present in Be2 plus? Yes, lithium के side में beryllium है ना. Lithium is having 3 electrons, beryllium is having 4 electrons. So out of those 4, 2 electrons are removed. So how many electrons will be present? 2 electrons are present in this given Be2 plus species. So it is isoelectronic with which species? H plus, Li plus, Na plus, Mg2 plus. Yes, can you tell me? So it is what? Isoelectronic with Li2 plus, because इसमें से एक चला गया ना, इसमें से एक चला गया, then we will get Li plus, that is it will be containing 2 electrons only. Next, which of the following will have maximum dipole moment? So CO2, CH4, NH3, NX3. Which will have maximum dipole moment? You know, CO2 being a linear molecule, it will have dipole moment 0. Okay, CH4 is tetrahedral. It will also have dipole moment 0, because all the dipole moment which are present to a different direction. Okay, that way they will cancel out the dipole moment of each other. Now NH3 and NF3, which will have the highest dipole moment? So here NH3 and NF3, even though fluorine is present, we have talked this so many times, even though fluorine is more electronegative, you will think that it will show the more dipole moment, but that is not the case. NH3 show the more dipole moment because the alignment of lone pair present on nitrogen as well as the dipole moment of these 3 hydrogen atoms are all in what? They are aligned. Okay, but when you put here fluorine, what happens? Dipole moment cancel out with the dipole moment of lone pair. That's why NH3 is our correct answer here. Okay, which will show the highest dipole moment. Next, which one of the following species has plain triangular shape? So plane, not plane, it is planar. Okay, it will have planar triangular shape. So which will have planar triangular shape? N3, NO3 minus, NO2 or CO2? Yes, can you tell me? So here the molecule NO3 minus, you can see here it is what? Triangular planar in shape. So this is what the molecule which will have the shape triangular planar. Okay, planar, triangular on triangular, planar. Next, acidity of diprotic acid in aqueous solution increases in the order. So here we need to consider the acidity of diprotic acids like H2AC, H2AC, and H2 tellurium. Okay, so when we talk about these acids, diprotic acids acidity, now you can see here H2O, its acidity is less than H2S, then H2 selenium, then H2 tellurium. So this is what the strength of acid for these diprotic acids. So when you see the options, now you can see S, then selenium, then tellurium. Option A you can see here, which is having what? Option A, which is having what? The same acidic strength matching with this one. Okay, that's why our answer will be what? Option A. So for diprotic acid, this is the order of acidic strength. Next, what is the relation between Kp and Kc? So you know that Kp is equal to Kc into RT raised to delta M. This is what the relation between Kp and Kc. Okay, that is what option A. And now in this, we have seen this relation also in equilibrium. And we have solved so many problems about this. Okay, try to remember this. Okay, now let's move on to the next problem. Artificial sweetener which is stable under cold condition only is. So here, which artificial sweetener is stable under cold condition? So aspartame. Okay, that is what option C is stable at cold conditions, but it becomes unstable at cooking temperature. So this is our correct answer here. Right. Next, in the following reaction, product A is yellow dye. So here पे diazonium salt है, which reacts with the aniline in the presence of H plus ion. What is going to form? So see here I have shown the reaction. So this diazonium salt and aniline, they react with each other in presence of acid to form, like this way the reaction goes. In this way there is a delocalization of electron and formation of bond takes place. And again, the aromaticity is intact in the molecule. So this is what electrophilic substitution reaction. Here is what coupling reaction of aniline takes place at the para position of NH2 group in benzene nucleus known as azodides. So this is known as what? Azodides. Formation of azodides. And all are what color? Means azodides are colored in nature, and they right now the molecule which is formed is what? Yellow color in nature. Okay, that is yellow dye. Okay, so here which is the product? It goes on to the para position. Okay, it goes on to the para position. So where is the para position? So coupling reaction is taking place. This is not para. This is again not para. This is not. So see here, this is what? Para position. So option D will be correct answer. Right? Okay, let's move on to the next problem. Which of the following will be most stable diazonium salt? So here you can see primary diazonium salt, phenyl diazonium salt. Then here again primary diazonium salt, ethyl वाला है. यहाँ पे क्या है? Benzene वाला सॉल्ट है. ठीक है, हमारा बेंजीन वाला जो सॉल्ट होता है ना, ठीक है, दैट विल बी व्हाट? करेक्ट आंसर हियर. ओके, दैट विल बी व्हाट? करेक्ट आंसर हियर, व्हिच इज अटैच्ड टू बेंजीन रिंग. इफ यू सी द स्ट्रक्चर ऑफ दिस सेकंड कंपाउंड ऑप्शन, फिनिल को क्या किया है? इस तरह से N2 plus X minus लगाया है in this molecule. Okay, here what has happened is benzene ring is present. Go to that benzene ring, CH2 is present, and after CH2 the diazonium salt is present. Okay, and this is again primary diazonium salt, and this is not stable. Most stable diazonium salt is which salt? Which is attached to benzene ring. Right? Any doubts in this? Okay, let's move on to the next problem. D-glucose reacts with hydroxyl amine. Okay, and it produces oxime. The structure of oxime would be, so first of all, you should remember the structure of D-glucose. Very, very important structure. Okay, here you can see the structure of D plus glucose. What is present? OH, 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 H, OH, and CHO. Remember this, OH, 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 H, and OH. So this is D plus OH. When it reacts with oxime, it gives us this oxime. Okay, it gives us this oxime. Okay, when it reacts with hydroxylamine, it gives us this oxime. What is happening? Here only change happens in the CH group. CHO is removed by double bond NOH. And double bond O replaced by double bond NOH. So that is only the difference. So here double bond NOH is present, double bond NOH is present, double bond NOH is present, double bond NOH. So that is already present in all the four options. We need to consider the arrangement of these groups OH, 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 H, OH. Which is matching with this? Yes, which is matching with this? OH, OH, H, H, OH. This is not. OH, 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 H, H. This is not. OH, OHH, OHH. This is again not OH, 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 OH. Yeah, this is the correct answer. So this is what the hydroxylamine when reacts with D plus glucose, we get what oxime, and that is the oxime of D plus glucose. Okay, option 7. Very easy problem. Next, for the following species. So 1, 2, 3, 4, there are 4 species given. Okay, OH is present, OH is present. Here COOH is present, and here again COOH is present. What is the correct order of acidity here? Okay, when we talk about the acidity order, you know that COOH is more acidic than OH. So ये 3 और 4 में वाले जो acids होंगे, ये जो compounds होंगे, the compounds will be more acidic in nature, and they will have the more acidity as compared to the OH group. Again, you can see that minus M of triple bond group is more than the minus M of phenyl group. Okay, so minus M of what? Triple bond. So this triple bond in between these two compounds now, it is having more than this, so it will have less. Okay, so पहले तो COH हो गया हमारा ऑर्डर, उसके बाद OH के आएंगे. OH में कौन से पहले आएंगे? पहले ट्रिपल बॉन्ड वाला आएगा और बाद में फिनिल वाला आएगा. मतलब क्या? पहले सेकंड वाला आएगा, देन फर्स्ट वाला आएगा. Now let's talk about what this. Here also what will happen? Yes, here also what will happen? Here again triple bond will come, that is fourth will come, and then phenyl ring will come, that is third compound will come. So 4, 3, 2, 1. 4, 3, 2, 1. 4, 3, 2, 1. Okay, so here, yeah. So here what will happen is what? ट्रिपल बॉन्ड वाले कंपाउंड पहले आएंगे और बाद में फिनिल वाले कंपाउंड आएंगे. तो ट्रिपल बॉन्ड वाले कौन से कंपाउंड है? पहले आएगा COH वाला ग्रुप, बाद में आएगा OH वाला ग्रुप. यहाँ पे भी पहले आएगा COH वाला ग्रुप, बाद में आएगा OH वाला ग्रुप. तो CH वाला ग्रुप है फोर्थ, देन आएगा हमारा यहाँ पे, सॉरी फॉर दिस, फर्स्ट ऑफ ऑल आएगा फोर्थ ग्रुप. Okay, see here, first one fourth, then second, then third, and first. This is our correct order. Option D. बराबर है? Okay, so that is not correct actually. Our option will be option A. Okay, sorry for this. Yeah. पहले आएगा हमारा COH ग्रुप, बाद में आएगा हमारा OH वाले ग्रुप्स. Sorry for this. Okay, any doubts in this? Yeah. Option A will be correct answer. 4, 3, 2, 1. 4, 3, 2, 1. पहले COH, then OH. Okay. 4, 3, 2, 1. That is option A. Next question, 79. Which of the following is an example of thermocyclic polymer? So we have given the structures of polymers, and we need to identify which polymers are these. So first polymer is what? Neoprene rubber. Next is what? PVC, that is polyvinyl chloride. Next is what? Nylon 6,6, which is a fiber. Okay. Next is what? Baccarat, which is a thermosetting polymer. We know this. We have solved this problem in our polymer chapter. Okay. Option D is correct option. Next problem. The compound which does not react with hydroxylamine is CH3COH, CH3CO, CH3, CH3CHO, and HCHO. So hydroxylamine से किसका reaction नहीं होगा? Okay, which is not going to react with hydroxylamine. So see here, aldehyde reacts with ketone to give oxime. Okay, aldehyde reacts with ketone to give oxime. So any CO group is going to react with हमारा what? Hydroxylamine. But acidic group, that is COH group, will not react. Okay, that's why option A is correct option here. Next, observe the following and select. Observe the following and select the correct option. Yeah. So यहाँ पे reaction हो रहा है phenol का with dilute HNO3. We are getting X plus Y. Okay. Steam distillation is happening and we are getting Y. That is low boiling fraction Y. What is that Y fraction? Right? A, B, C, D are the answer. So when you check this answer, na, dilute HNO3 when reacts with the phenol, we get X compound this and Y compound this. That is ortho and para compound. When we do the steam distillation, what happens is that only we get what? This compound, that is ortho product, intramolecular hydrogen bonding, low boiling point. Okay, so that's why we only get ortho product. Okay, para product remains as it is. So our answer will be what? This OH NO2. Okay, low boiling fraction कौन सा होगा हमारा? Ortho वाला होगा. ठीक है, Y molecule. Next here you can see substituted phenol is there which reacts with pH N2. Substituted phenol is there which reacts with pH N2. So here what will happen? Coupling reaction is going to take place. When coupling reaction is going to take place, what is going to form is here there will be formation of this molecule. So N2 goes here, okay, attacks on this position. The incoming electrophile comes at the what ortho of this OH. So option A will be correct answer here. Any doubt in this? यहाँ पे क्या हुआ है, मेटा पे लगा है, यहाँ पे क्या हुआ है, पैरा पे लगा है, NH निकाल के यहाँ पे OH निकल गए. These two are not happening and मेटा पे तो नहीं होगा, ठीक है. OH is what ortho para directing, पैरा पे already NH2 था तो ortho पे आ जाएगा, right? A option is correct option. Very good. Let's move on to the next problem. What product are formed when the following compound is treated with Br2 in presence of FeBr3? So here, this compound, that is our cumene. This is what? Metacumene. When reacts with FeBr3, what is going to form? Okay, A product, B product, C or D. So mixture of bromines. Okay, so here you can see what is going to happen is Br2, FeBr3. This is what? Electrophilic substitution reaction. When this reaction takes place, there is a formation of para with respect to this CH3 and there is a formation of orthopara. Okay, or with respect to this is what? Ortho, and with respect to this, it is what? Para. Similarly, with respect to this is what? Ortho, and with respect to this is what? Para. So ortho-para product is more suitable. Okay, ortho-para product is more suitable. So here you can see this is not happening. 3 groups in same very steric hindrance. This compound is never going to form. ये भी नहीं form होगा. 3 simultaneously नहीं आने वाले हैं. ये product भी नहीं form होगा. मेटा पे Br नहीं आएगा. So here option C is what? Correct answer. Ortho-para product is going to form. Right? Any doubt in this? Okay, let's move on to the next problem. Here you can see what is happening is which of the following compound will undergo racemization when solution of KOH hydrolyzes. Here 1, 2, 3, 4 options are given. So out of these 4 options, which is undergoing into racemization when KOH hydrolysis is going to take place. So first option is what? Phenyl, benzyl chloride. Next is what? Primary chloride. Next is what? Isochloride. Next is what? Tertiary chloride. So here this is what? Primary. This is again primary. This is secondary and this is tertiary. Racemization when takes place? Racemization takes place when there is what? Our reactant molecule is what? Tertiary. Okay, our reactant molecule is what? Tertiary. So that's why this is what? SN1 type of reaction. So only 4 will be the answer. SN1 type of reaction, only 4 will be the answer. So only this compound is going to give us the racemization when it undergoes into hydrolysis with what? KOH. Right? Any doubt in this? Okay, let's move on to the next problem. Among the following sets of reaction, which one produces anisole? So 4 reactions are given. Let's see one by one reaction. First reaction you can see when there is a ketone is present. No, that is not ketone. This is what? Aldehyde is present and it reacts with what? Grignard reagent. You know that when aldehyde reacts with Grignard reagent, there is formation of what? Primary alcohol. Right? Here you can see there is a formation of alcohol. Okay, so there is a formation of, here is what? CH3 था यहाँ पे, इसलिए ये secondary alcohol form हुआ है. Okay, there is a formation of alcohol there. So हमको क्या चाहिए? Anisole चाहिए. So this is not the option we need to consider here. Next reaction is what? When phenol reacts with NaOH, right? And then followed by the addition of CH3I. What is going to form? So here you can see there is a formation of, this reaction is what? Williams synthesis. There is a formation of salt of phenoxide ion. And then on that CH3I get attacks and there is a formation of OCH3. So this reaction is what? Correct. That is option B. Let's see the C reaction. CH3OH, sorry, C6H5OH when reacts with neutral FeCl3, violet color complex is formed. There is no formation of anisole. Anisole nahi form ho raha. Next reaction you can see, what is this? This is the Friedel-Crafts acylation reaction. COCl and AlCl3, this is what? Friedel-Crafts acylation reaction. Methane, यहाँ पे क्या है? Benzene ring है. Benzene के पास already CH3 है. Okay, there is a CH3 already present. So this CH3COCl is going to attack on one of the position present here. So there is what? Not going to form. It is going to attack COCH3. ठीक है, यहाँ पे क्या ऐड होने वाला है? देखिए, यहाँ पे directly add होगा COCH3, not only OCH3. Okay, here going to add what? COCH3, not only OCH3, and that's why this is again not our reaction. So reaction B is correct answer for this, for the production of anisole. Yes. Okay, let's move on to the next problem. Here you can see the reaction of aqueous KMnO4 with H2O2 in acidic condition gives. So you know the reaction of KMnO4 with H2O2. Here you can see when KMnO4 reacts with H2O2 in presence of H2SO4. So we need H plus ions during the formation of this reaction. So there is a formation of what? Oxygen, MnO4, H2O and K2SO4. Oxygen, MnO4 and K2SO4. Okay, and H2. So here during this reaction, what is going to form? Mn2 plus ions are going to form and O2 is going to form. Right? MnO2 हो रहा है, नहीं हो रहा है. O3 तो नहीं हो रहा है, O2 हो रहा है. 4 plus है क्या? ये Mn क्या है? SO4 2 minus, Mn क्या है? 2 plus. So this is again not forming. So option B is correct answer. Any doubts? Among the following complexes, the one which shows zero crystal field stabilization energies. So CFEC problem, crystal field stabilization energy. Let's see for all these complexes which will have the zero field stabilization energy. So when we talk about manganese here, when we see the charge here, manganese is having 3 plus charge. Okay, Fe is having how much charge? Fe is having 3 plus charge. Okay, here CO is having 3 plus charge. Next, CO is having here 2 plus charge. H2O being neutral ligand, whatever the oxidation state present on the complex will be what the oxidation state for the given ion. Okay, so when we calculate the crystal field stabilization energy for second option, that is Fe2 plus, here you can see it is what having 3d5 electronic configuration. Okay, if I want to determine the T2G and EG type electronic distribution, so T2G, it will have what? 1, 2 and 3 electrons. Okay, at T2G it is going to, I will show you neatly. Okay, so here what is going to form is there will be what? At T2G 1, 2 and 3, and at EG 1 and 2. T2G and EG. Okay, so all electrons are unpaired. When you put for T2G, the CFEC stabilization energy is what? Minus 0.4, because it is below. That much decrease of energy happens for a barycenter, and here 0.6, that much amount of energy is increased. That's why it is a positive inside. So let's do the calculation. Multiplied by 3, multiplied by 2, 4 3s are 12, 6 2s are 12. When you do the delta 0 multiplied by delta 0, you will get answer 0. Right? So for option B, you are getting crystal field stabilization energy 0. You can calculate for Mn3 plus. For Mn3 plus, you can see there is what? 3d4. Okay. For CO2 plus, it is what? 3d7. This is what? 3d6, and this is what? 3d5. So for since 5 is what? Equal number of, means equal delta 0 value, we are getting 1.2 and 1.2, and that's why it is cancelling each other. Positive 1.4, 1.2 and negative 1.2, and that was what? Cancelling to each other, and that's why here D5 will have the zero crystal field stabilization energy. What will D4 have? You can see here for D4, let's put the value D4, 1, 2, 3 and 4. Okay, this is for D4. For D7, what will happen? 1, 2, 3, 4, 5, 6 and 7. So here T2G में ज्यादा इलेक्ट्रॉन होगा. यहाँ पे क्या हो रहा है? 3 electrons in T2G, 1 electron in EG. They will not cancel out each other, right? For D6 again, 1, 2, 3, 4, 5 and 6. Here again 4 electrons in T2G and 2 electrons in EG. So that will not cancel out each other. When D5 electronic configuration is there, that is going to cancel out each other. That's why B answer is here. What? Correct. Okay, everyone, any doubts? Okay, let's move on to the next problem. Magnetic moment is 2.83 Bohr magnet, which will be given by which of the following ions? So Ni2 plus से, manganese से, titanium से, chromium से. If we want Bohr magneton, that is magnetic moment, that is 2.83. Okay, that is we want magnetic moment 2.83. If you want 2.83 as a magnetic moment, then there must present 2 valence electrons. There should be 2 valence electron present in the given ion. So when we talk about that, number of valence electrons should be 2. So consider the electronic configuration of each and every species. So titanium, it shows D2 4s2, right? Titanium shows D2 4s2. So out of that 4s2 वाले electron तो चले गए, तो इसमें है 3d2 electrons. Okay, it is having 3d2 electrons, but out of that what is happening here is what 3 plus charge, that's why it is having D1 configuration. For chromium, chromium is showing D5 4s1. In from that D5 4s1, D5 4s1, 3d5 4s1, 3 electrons has been removed. So 3 electron remove करो, ये निकल गए, इसमें से 2 निकल गए, बचे कितने 3. So 3d3. So here no 2 electrons are present in Cr3 plus. Okay, 3 electrons are present, not 2. For Ni2 plus, it is what 3d8 4s2. तो s2 वाले तो चले गए, कितने बचे 3d2 बचे. 3d2 को पुट कीजिए, इलेक्ट्रॉन्स को फिल कीजिए. 1 2 3 4 and 5. So 1 2 3 4 5 6 7 and 8. Yeah, so here you can see there are how many electrons present? 2 electrons are present, which are what? Valence shell 2 electrons, 2 unpaired electrons. These are what? 2 unpaired electron present in this molecule, and that's why it will show a magnetic moment 2.83. When we talk about another complex or ion Mn2 plus, it is having what? 3d5. So it is having 5 electrons in its outermost orbit. So that is not correct. Okay. So our answer will be what? Option B. Yes, everyone? Any doubt in this? Okay. Our option answer will be option B. So for 89 question, option B is the correct answer. Next, which of the following complexes is used as anti-cancer agent? So you know cisplatin is used as what? Anti-cancer drug. And which is the cisplatin compound? Platinum cis Cl2 NH3 twice. So this is what our anti-cancer agent. Okay, option B is correct answer here. Okay, any doubts? Okay, let's move on to the next problem. Reason of lanthanide contraction is negligible screening effect of f orbital, increasing nuclear charge, decreasing nuclear charge, decreasing screening effect. Okay, so here reason of lanthanide contraction is what? Here lanthanides are, even though having all the orbitals present in them, s orbital, p orbital, d orbital, and f orbital, they are from f block elements. They do not have more size as compared to the radius when we consider. Okay, so reason being for lanthanide contraction, that is small size of the lanthanoids radius, is what? There is a negligible screening effect of f orbitals. There is what? Negligible screening effect of f orbital. So this is our answer. A poor screening effect of f orbital, which results into the lanthanide contraction. They do not show a good screening effect, and that's why their size is what? Less. ठीक है, अगर वो ज्यादा स्क्रीनिंग इफेक्ट दिखाते तो क्या हो जाता था? बाहर वाले जो वैलेंस इलेक्ट्रॉन है, बिकॉज एफ ऑर्बिटल्स आर व्हाट? इनर शेल, राइट? इनर ऑर्बिटल शेल्स. एफ बाद में डी है, बाद में एस है, बाद में पी है. ठीक है, बट एफ ऑर्बिटल डू नॉट शो दैट मच अमाउंट ऑफ स्क्रीनिंग इफेक्ट, एंड दैट्स व्हाई अदर ऑर्बिटल इलेक्ट्रॉन व्हिच आर प्रेजेंट सराउंडिंग टू द एफ ऑर्बिटल, दे आर still in a close contact with the nucleus, and that's why lanthanide contraction is happening. Okay, next, metallurgy is the process of concentration of ore, roasting of ore, both A and C, and extraction of metal from ore. So you know that metallurgy is what? Extraction of metal from ore. So option C is correct. Okay, option C is correct. Next, sodium metal crystallizes is body centered cubic lattice with cell age. So A का value दिया हुआ है 4.29 angstrom. Very good. BCC crystal lattice है. What is the radius of sodium atom? BCC में number of atoms कितने होते हैं? Number of atoms are equal to what? 2. We need to find out R. The relation between R and A, you know, R is equal to what? Root 3 by 4A. Put the value of A here. Root 3 divided by 4 multiplied by 4.29. Okay, it is in angstrom, converted into what? Centimeter. Converted into what? Centimeter. 10 raised to what? Minus 10. Okay, when you do this calculation, you will find out that option, which option is correct? 93. Option A is correct. Okay, 1.857 into 10 raised to minus 8 centimeter. कैलकुलेशन कीजिए, आपको आंसर मिल जाएगा ऑप्शन ए. Okay, let's begin with the next problem. All halogens are colored. This is due to. So you know that halogens are what? Colored compounds. Why that is happening? So halogens, whenever any compound is colored, why is that happening? Because they absorb the radiation from the visible light. Okay, they absorb the radiation, and that's why when they absorb the radiation, there is a transition takes place in that given compounds, and when these compounds come to the ground state, they emit the color. That is the simplest phenomena of colored compounds. So large negative value of electron gain enthalpy, no, this is not correct. Absorption of radiation in visible region, yes, this is correct. Large electronegativity, those is not correct. Absorption ultraviolet, no, this is not happening. Ultraviolet radiation में अगर वो absorb करते तो हमें दिखता ही नहीं. Okay, that's why all halogens are colored, and we can see them that they are colored. Why? Because absorption of radiation is taking place in visible region. That is the main reason for that. Okay, so colored compound are colored. Why? Because their absorption, which is the radiation which they are absorbing, that is happening in what? They are absorbing the radiations of visible region. Okay, which we can see. Which we can see in the visible region, that radiation they can absorb, and that's why all are what? Colored in nature, right? All are what? Colored in nature. Next, you can see the reaction, 95 question. Here in the following reversible reaction, 2SO2 plus O2, 2SO3 plus Q, halon. Most suitable condition for the higher production of SO3 is high temperature and high pressure, high temperature and low pressure, low pressure and high temperature, low temperature and low pressure. Okay, so here you can see that for this given reaction, in order to have the highest production of SO3, what we should have is we should have low temperature and high pressure. We should have low temperature and high pressure. So this is our correct answer. Okay, option C is correct. Right, let's move on to the next problem. Which of the following will not be suitable in sodium hydrogen carbonate? Will not be soluble in. Okay, not suitable, not soluble in sodium hydrogen carbonate. 2,4,6 trinitrophenol, orthonitrophenol, benzoic acid, and benzene sulfonic acid. So when we talk about sodium hydrogen carbonate, that is H2CO3. So acids which are stronger than H2CO3 give CO2 gas with sodium hydrogen carbonate, and also soluble in sodium hydrogen carbonate. Okay, so acid stronger than H2CO3. So here you can see orthonitrophenol is not soluble in sodium hydrogen carbonate. Okay, this is not sodium hydrogen carbonate, sorry. NaHCO3, sodium hydrogen carbonate. Okay, so acid stronger than H2CO3 gives CO2 gas with sodium hydrogen carbonate, and also soluble in what? Sodium hydrogen carbonate. So which is not soluble? Orthonitrophenol will not be soluble because it cannot form, or which cannot be soluble here due to it cannot give the CO2 gas. Okay, yeah. Next problem, which of the following is most reactive towards nucleophilic addition reaction? This compound, this compound, this compound, or this compound? Which will be more stable, more reactive towards the reaction? CHO benzene के पास है वो, या COCH3 या NO2 वाला है, CH3 वाला. You know that nucleophilic addition reaction should be taking place. What should happening? Nucleophile. Okay, so in order to take place the nucleophilic addition reaction, we must have good electrophile. Okay, we must have good electrophile. So what do you think? Which is good electrophile? Good electrophile means what? It should be electron deficient. It should be electron deficient. Electron deficient means what? It should be containing it should be containing the electron withdrawing substituents. It should be containing the electron withdrawing substituent. यहाँ पे कोई electron withdrawing substituent है? नहीं है. That is simply our what? Benzyl diol. Here ketonic group is present. Okay, यहाँ पे कोई भी उसको इलेक्ट्रॉन विड्रॉ करने वाला ग्रुप प्रेजेंट नहीं है. ठीक है, यहाँ पे क्या है? CH3 which is what? इलेक्ट्रॉन डोनेटिंग. इलेक्ट्रॉन वो दे देगा, इलेक्ट्रॉन दे देगा तो इलेक्ट्रोफिलिक हो जाएगी क्या? The molecule will become electron deficient? No, because CH3 is giving the electron. Lastly, you can see here NO2. What does NO2 do? It withdraws the electron towards itself from the ring. And that's why the center here, the center becomes more and more electrophilic. And now nucleophile can attack on this given compound. Now nucleophile can attack on this compound. So for electron withdrawing groups, that is which show minus I and minus M effect, increases the reactivity towards nucleophilic addition reaction. And the group that is present in this options is what? NO2 group, which shows minus I as well as minus M, okay, increases the reactivity towards nucleophilic addition reaction at CHO group. That's why our option D will be what? Correct answer here. Are you getting this? Option D will be what? Correct answer here, because due to the presence of NO2 group, which is what? Electron withdrawing. This is what? Electron withdrawing due to what? It is withdrawing the electrons, and the center CHO becoming what? Electron deficient. And electron deficient means what? Electrophilic. Electrophile के ऊपर अच्छा nucleophile add होने वाला है. ठीक है? So this is what D option will be correct here. Next, identify the Z in the sequence. Yeah, see here, alkene is there, which reacts with HBr in presence of H2O2. So here, anti-Markovnikov rule is going to use, which on reaction with C2H5ONA, what is going to form. So see here, what is happening in this reaction. Okay, in this reaction, you can see alkene reacts with HBr. What is going to happen? Anti-Markovnikov's addition. What is the meaning of this? H plus and Br minus. So Br is going to go on the alkene, which is having more number of hydrogen. तो यहाँ पे एक ही हाइड्रोजन था, यहाँ पे 2 हाइड्रोजन से कार्बन पे, तो ये Br माइनस ऐसे कार्बन के पास जाएगा जिसके पास ज्यादा हाइड्रोजन होंगे. तो इस तरह से हमारा ब्रोमो अल्केन फॉर्म हो गया. When it reacts with C2H5ONA, there is a formation of what? CH3, CH2O, CH2, CH3, and this compound. Okay, so HBr in presence of peroxide gives anti-Markovnikov addition product. And this primary alkyl halide on reaction with C2H5 gives SN2 reaction. Okay, gives SN2 reaction. So this is again repeated written. Okay, so SN2 reaction में हम लोगों को क्या मिलने वाला है? CH3, CH2, ठीक है, CH3, CH2O, CH2, CH3. तो यहाँ पे हमको मिलेगा ये दो CH2, CH3. Okay, CH3, then CH2. Then again, these are what? 2. ये CH3, ये CH2 और ये CH2, ठीक है. और इस CH2 को के पास क्या लगेगा? OCH2, CH3. So that's why here answer will be what? A. ठीक है. यहाँ पे है 3. CH2, CH2, CH2. 3 O CH2, CH3. ठीक है. Are you getting this? Okay. I will just write it here. ये देखो नीचे लिखा हुआ है. Here it is written already. Yeah. CH3, CH2 thrice, OCH2, CH3. Okay, so option A is correct answer here. Very simple reaction. Let's move on to the next problem. Which of the following organic compound has same hybridization as its combustion product CO2? Okay, ethane, ethine, ethene, ethanol. So you know that CO2 is having which type of carbon? So like that way, ethine is having. So ethine, both the carbon atoms are what? sp hybridized. Both are what? sp hybridized. Okay, and the hybridization of CO2 carbon is what? In sp hybridization. So that's why here answer B is correct. For 99 question, ethine is having sp hybridization similar to the CO2. Here, if we paramethoxytoluene is nitrated, the major product obtained is paramethoxytoluene. Here you can see the structure. This is what? Toluene molecule. ठीक है, उसको क्या किया है? मिथॉक्सी ग्रुप ऐड किया है, which is present at para position. That's why it is known as paramethoxy. और बेंजीन को अगर हमारा CH3 ग्रुप अटैच होगा उसको हम बोलते हैं टोल्यून. So paramethoxy when reacts with what? Nitrating agent. That is HNO3, H2SO4. Here you can see HNO3, H2SO4. This is nitrating mixture. What is going to happen? There will be introduction of electrophile, that is what? Plus this NO2 is going to attack. Okay, this NO2 group is going to attack. That is electrophile is going to add. So where this electrophile is going to add? यहाँ पे, यहाँ पे, यहाँ पे, या यहाँ पे, 4 position है. So this electrophile attacks on the ring which has more plus M effect. So कहाँ पे CH3 का plus M effect किसके पास है? NO2 पे. यहाँ पे मेटा पोजिशन पे. So that's why here मेटा पोजिशन पे जो NO2 आएगा, that will be the good option. Okay, good product or major product form here. So here that's why for this problem answer will be this. NO2 molecule present at the meta position will be the highest or major product form here. Right? Any doubt in this? Okay. So thank you so much for joining this session. I have solved most of the problems present in today's test. If you have any doubt, you can ask me. Okay, let's wait for tomorrow's session. Thank you so much.